Hey everyone, and welcome back to Code in Silicon, your journey from transistors to Python. Today we're answering a question that seems simple but is at the very heart of computing. How does a computer actually run a program? We're going to follow a single line of code, x equals 5 plus 3, on a journey from your keyboard all the way down to the microscopic transistors inside your CPU. Let's get started. It all starts here with a simple human-readable line of Python code. X equals 5 plus 3. It makes perfect sense to us, but your CPU has no idea what this means. It speaks a different language. So, the first step is translation. A program called an interpreter or compiler breaks our simple line down into fundamental low-level commands called assembly language. These are like the basic verbs of the CPU: load this, add that. But the CPU doesn't even understand the words load or add. It only understands one thing: on or off, 1 or 0. So, these assembly instructions are converted into their final form, machine code. These long binary numbers are the actual instructions. They're just data stored in your computer's RAM, waiting for their turn to be executed. Now the magic begins. This is where the hardware comes to life. The CPU's control unit starts a relentless, lightning-fast loop called the fetch-decode-execute cycle. Instruction 1. Load R15. First, fetch. The CU grabs the first binary number from RAM. Then decode. It translates the binary pattern, figuring out it's a load command for register 1. Finally, execute. It sends electrical signals to put the number 5 into R1. Instruction 2. Load R23. It does the same thing for the next instruction, loading the number 3 into register 2. Now, both numbers are in the CPU's superfast temporary memory, the registers. Instruction 3. Add R1, R2. For the add instruction, the decode step tells the CU to use the ALU, the arithmetic logic unit. The CU sends the values from R1 and R2 into this unit. Inside the ALU, a massive, intricate web of tiny switches called transistors flips on and off according to the rules of binary math. In a nanosecond, the addition is complete, and the result, 8, is placed back into register R1. And that's the complete story. We went from a single line of Python code, down through translation into binary, and into the physical dance of electricity and silicon inside the CPU. Everything your computer does, every app, every game, every video, is just this process repeating billions of times every second. So, for a bit of homework, the next time you're with a friend, I want you to explain how a computer adds 5 and 3 in just one sentence. Here's my take. The computer translates your command into binary, which flips tiny switches inside the processor to physically create the answer. If you are enjoying this course so far, let me know in the comments. Thanks for watching, and I'll see you in the next video. Part 2 recap of the bridge: how hardware meets software.